Let's look at how radon enters a house. In this example, we have a fissure in the ground where radon comes up, a gravel layer underneath the house, and footings. The middle footing is a strip footing. The footing on the right has some penetrations and therefore is not airtight. Radon enters the house through openings, such as a crack in the basement slab. So, how does this get mitigated? The usual mitigation process would begin with a communication test, where holes are drilled through the slab. The mitigator would make a larger hole and apply a shop vac to see if there is a connection to the other holes. Normally that test would be made wherever the most convenient place for a mitigation system would be. In this case, that might be the hole on the far left. In this example, the communication test would reveal that there is communication to the middle hole, but not the far right hole, due to a type of blockage. In this example, it's strip footing, but a blockage could be caused by many things. So, the mitigator would then put the shop vac on the middle hole and hope that it would communicate with the other holes, but in this case, we're still not communicating with the hole on the right. To resolve this, the mitigator would run a jumper to a part of the slab where there was no communication. The theory is that radon is diverted from the crack and is exhausted. The flow through the crack is reversed and the basement air is drawn below the slab and exhausted with the radon fan. The problem with this method is that a lot of energy is wasted sucking in clean air from the outside, and in the winter this leads to cold walls and floors. It also lowers the suction on the other side by pulling in outdoor air, plus now you have a large unsightly jumper. Even worse, the problem might not have even gotten solved. In theory, the mitigator depressurized the entire slab and reversed the airflow through the cracks, but this isn't necessarily the case. The actual pressure at the crack was never measured. There might not even be access to the crack if it is at the expansion joint under a finished wall. Another consideration is that the mitigator may have depressurized the whole slab now, but what about 6 months from now when the water table is different? What about when the house's HRV intake is plugged, depressurizing the house? Maybe then the entire slab will no longer be depressurized with respect to the house. By sucking on the sub-slab, the mitigator could be bringing in more radon from below. So yes, the airflow through the crack is decreased, but there may have been an increased concentration of radon in that air. Instead of starting with a communication test, some of our customers start by using the radon sniffer to check for radon sources. Where a source is found is where the test hole would be placed. Then the mitigator would check for communication to that hole. If there is no communication to a hole that doesn't make up any radon, then there isn't a need to worry about it, and the mitigator would just seal it up. Then the mitigation system would be put where most of the source is, or at least where there is good communication with the source. Therefore, the radon will be moved directly, without first being dragged all over the underside of the slab. Because the test point is close to the radon source crack, the likeliness of not having enough suction to maintain the airflow in the right direction is much less. There also isn't a waste of suction bringing in clean air from the outside.